Hello, folks. Welcome to session 2 of the operating classes. I'm Roll Anders, and your co-host Tom Christovich, K3YH, is there. And we also have presentations tonight on 2.5 subjects. One of them, for number 1 subject, is about the other side of VHF and UHF operation. That you all know about FM repeaters, but there's a world of VHF and UHF beyond repeaters. And my good friend Brian Skutt, N3IQ, is going to lead us through that. How are you tonight, Brian?
Hi, Raul. Thanks again. It's always a joy and a pleasure to address this august group. And this must be about our roughly 20th time, you think?
Oh, I don't
15th
know.
at least?
I'm losing track. It goes way back. And we have 2 other presentations. Jim Andrews is going to present Fast Scan TV, and he's updated his presentation completely since the last time we've seen it. If you've seen it before, he's a real pro when it comes to Fast Scan TV. And then I'm going to show you an excellent video from Down Under on Slow Scan TV. And each one of these presentations will take about an hour. So in order to get them all finished on time, I think I should stop yapping and turn it over to Brian.
Thanks, Raul. I'm going to put up some slides and occasionally switch over to some specific subject matter on another screen. So give me a break when I'm switching because I'm not very adept at it.
Okie dokie.
Okay, so as I mentioned, we've been doing this for a while, and the subject is VHF, UHF, and above fun. And for a long time, since about the early 1990s, I've made a lot of fun doing roving. In the old days, it was a little bit different than it is now, but it's still a lot of fun. We're going to talk about that. The picture on the slide is the Tower of Power located near Washington, D.C. at the site of W4RX. And I'm sad to say that that Tower of Power may be going away because Jim Algren, W4RX, who's an amazing man, passed away, became a silent key late last year. And it looks like they're not going to maintain that site as a contest site. So I hope many of you had the chance to work either W8ZN or one of the contest stations like K8GP or Jim himself, W4RX, at that site. It was a great place to operate from, and that antenna was amazing. We're going to talk about VHF stuff, and this is sort of the required VHF basics slide. A lot of good VHF bands, and there's activity on many of them. And the story behind all this is, if we don't use these bands, we're going to lose them. We already kind of lost one in the last few years when the band 3456 megahertz got moved due to a spectrum sale, and everybody had to change their equipment and antennas around to keep operating. And some of these bands don't have a lot of activity, so one of the folks, excuse me, I'll see if I can go back. There we go. My favorite band is probably 6 meters. It has the nickname of the Magic Band, and it is. It seems like almost every day something fun happens any time of the year, but we're going to talk a little bit more about some 6 meter things. And the activity on 6 meters now has become a lot of digital mode, especially FT8 on 50.313, but there's a lot of other things that you can do on 6 meters, and we're going to talk about some of them. And 2 meters is a lot of fun. A lot of people do some amazing things on 2 meters, including a lot of Earth-Moon earthwork. And as you go down that list there, you can see all the bands. There's kind of a fun fact on most of the slides. A long time ago, as a club project, we made some weak signal sources, some phase-locked oscillators out of some bricks that we got at Hamfest for $5 or less. And that's a picture of one of them. I think in the 90s we had a club project to make a bunch of these. And basically the oscillators in those bricks rang a diode, and the frequency was 1152. And amazingly, if you look at these bands, many of them are direct multiples of 1152. So it was very practical to have one single box that could generate a little bit of a signal at many of the microwave bands. I think Tom probably said it, but if you have a question or a comment or you want to share a story, use the chat window. It'll go directly to Tom, and Tom will interrupt when it's time to answer a question. So please feel free. You can see where the weak signal activity is, the band plans for the different license things, and sort of some key frequencies. Probably need to update this from time to time, but I believe this is close to correct for right now. A lot of activity on the digital modes, as I mentioned, even up to at least 70 centimeters and sometimes above. And the big change since when I first started operating is a lot of the radios now have some sort of a spectrum or a waterfall display that you can use to point and click. And I certainly didn't have that when I first started, but it sure is nice to get a visual display of what's going on in the bands, and it's very useful when you're operating. I'm a big fan of the VHF, UHF beacons. Unfortunately, they're kind of phasing out. I use the beacons for all sorts of things to predict or to know when there's a band opening. When you're out roving, it's a great way to find out where you are and what direction to point in. There's a lot of beacons out there, and a lot of clubs spend a lot of time and money to keep their beacons on the air. And it's changed. A lot of beacons have gone off the air and haven't been put back on. I used to be able to hear, I think, 14 beacons on 2 meters, and now I only hear about 5 from my house here in FM 19. So that's kind of an interesting thing. However, there's kind of a new thing about beacons, and that's the fun fact. There's actually some FT8 mode beacons, especially in Europe. I0JX, who is a big gun on 6 meters and often is one of the first signals to come through when there's an opening from here to Europe, actually has a 6-meter beacon that he uses the FT8 mode in his beacon. So that's a pretty cool thing. I've got a picture here of a rover that's fully outfitted. That rover exists. My friend W8ZN has that rover with the extendable towers and equipment for all the bands and K3 radios inside, computers. It's a highly automated, very capable system, and the key is integrating everything with the computers, making it easy for the operators so you don't get tired when you're operating. A lot different than the old days when pretty much everything was manual, including logging. It's a pretty neat thing. And they're located on Hogback Mountain. I recognize that spot. And Hogback is pretty cool. If you look along the horizon, you'll see a little gap. And that gap is right up the Atlantic coast towards Philadelphia, well, Baltimore, Philadelphia, and New York City from this site in Virginia. I'm not an employee of ICOM, but a lot of guys, when they're serious about going microwave, have looked at the ICOM 905 radio. It's kind of becoming a very important piece of equipment for people who like 10 gigahertz. It has 10 gigahertz built in, and instead of what I have done is I have a box on the tower that has all the transverters, amplifiers, switching, preamplifiers, all the goodies are in a box on the tower, which makes it very difficult to maintain. If something fails, you're basically out of luck unless you can climb the tower during a contest. In this, the ICOM 905 is completely different. The box is still up on the tower, but it's connected by a Cat5 or a Cat6 cable, Ethernet cable, and so you're sending data instead of RF up the tower, and it's a little bit different and very slick and convenient, and it works extremely well. I have used one, especially on 10 gigahertz, and a completely new way and pleasant way of operating. And again, you get the display, frequency display, digital display with a waterfall or spectrum, and very helpful. You can find out where people are, and it's kind of the modern way to go if you can afford it. It is not cheap. However, they do go on sale once in a while. So the obligatory math slide. I like this stuff. I'm a math guy. If you saw that tower of power, it has about 20 dB gain. It looks like somebody got a little green line on my slide. That was unintentional. So I have a tower here. Well, I'll show you a picture perhaps in a moment from the mapping program. And if you have a full-size 3-element Yagi, it's about 25 feet boom and about 35 long elements. If you have it on a 70-foot high tower, you'll get maybe 8 dB gain. Is that me drawing on the slide? I don't mean to be.
No, it's somebody. I'm trying to disable that. Somebody's got a pen on there. If you could kind of refrain from drawing on the screen, I'd appreciate it, guys.
It's pretty cool. I don't know if you can see behind me, but my grandchildren draw on my whiteboard, and you can see that in the background if it's viewable. So anyway, when I first got into microwave, we all put together some dishes that were about a little bit bigger than 2 feet in diameter, about 1 meter in diameter, 40 inches. And with those antennas, we would get 34 dB gain, roughly 2,000 times the power. And that antenna would have about a 1 degree beam width. And so that with a 2-watt transmitter, in those days 1 watt was pretty standard, 2 watts easy, and you would have 4,000 watts ERP. Comparably, unless you have a big amplifier and a big antenna at HF, it's pretty tough to get 4 kilowatts ERP. So one of the cool things about microwave is, in a way, you can have a very efficient and powerful system that is very small. And what this map here is showing, a 10 gigahertz dish at 2 feet has about 36 dB gain, less a factor for efficiency, really about 3 dB. So 33, 34 dB gain is what you can practically expect from a 2-foot dish. So if you put in that 2-meter tower of power at about 144 megahertz, I'm sorry, the line isn't perfectly drawn, but it goes way out here somewhere and says you need about roughly a 50-foot dish for 20 dB gain, subtracting the efficiency factor. So the scaling of antennas is pretty cool. And here's sort of the decades of scaling. At 20 meters, like I said, 35 feet. At 2 meters, you're talking about 2.5 feet long and about 3 feet wide. At 23 centimeters, the 1296 megahertz band, it's about 4.5 inches wide. And like we said, at 10 gigahertz, a 2-foot dish has 33 dB gain. So as you get higher up in frequency, you can pack a lot of punch with a small antenna. And here's some links for calculations of antenna information. If you ever get to the W1GHZ site, Paul has put together a massive site with all sorts of helpful circuit diagrams and antenna design information and how things work on his site, and it's a lot of fun to spend a couple hours looking at what he's got there. So let's talk about VHF propagation, which is why 6 meters is the magic band. All sorts of stuff happens on the magic band and on the other VHF bands, and we're going to talk about some of those things. We all know about line of sight and how FM works and how you have to be kind of inside of the repeater in order to hit the repeater and then work the guys that are also in line of sight of the repeater. Or if I want to talk to my club station over on the mountain, that's about as far as I can go, 60 or 70 miles, because that's the limit of line of sight around here at microwave because of the curvature of the Earth, which you can kind of see in the picture. There's tropo and all sorts of ducting, often along the path of when there's a storm and there's a trough in weather pattern, you can often find that there's interesting propagation along that trough. There's aurora caused by the northern lights, or the southern lights, I guess, but the northern lights. And this year, the aurora was actually quite significant, and I was able to make over 100 contacts this year on aurora, mostly on 2 meters. Unfortunately, hardly anybody knew. If you've been doing it for a long time, you tend to work the same guys. But when the aurora gets strong, maybe it'll reach out to some new guys. And as the sunspots have been kind of crazy the last couple of years, there's been quite a bit of aurora. And in the summertime, usually about the longest days of the summer, you'll find that the sunspot indicators and indices get pretty high. And you'll find that you get skip during the day when the sun is bright in the E region or the F region. And that can really enhance the propagation, and you'll get really loud signals over fairly long distances on 6 meters, and sometimes very, very rarely above 6 meters. So what I do, again, is I use the beacons to identify openings. I don't think a lot of people do that. The joke in the old days, I don't know, maybe you have a story about this, Roll. I used to listen for European baby monitors at 49 megahertz, just below the 6 meter band. And for some reason, when the band was open, you could hear those very low power 49 megahertz baby monitors across the ocean, and hear a French baby crying, which doesn't sound the same as a American baby crying. So I'm gonna click on this link right here, dxmaps.propsounds. Actually, I'm not. I'm going to go to a different screen. So just give me a second here. Oh, there's some chat. Did we need to stop Tom for a second?
No. Go ahead and keep. Are people sending chats directly to you?
No, it said 3 on my chat window when I went to go share. So yeah, I think those are the ones you sent.
I will have one question in a little bit, but go ahead and continue.
Okay, I am doing that. Okay, so I am going to go to, let's see, working. Okay, so this is a briefing by Mike, WB8BZK, who's also a rover and a very active ham. And this side is on the, I believe, the Madison DX Club, a site which again has many, many very cool briefings and resources for hams. And I'm going to play it for about 5 minutes to talk a little bit about meteor scatter using the MSK 144 mode. Can you guys see that screen okay?
It's not, part of it's cut off on the left side.
I think it'll be okay when you start it. It was
playing it. Let's see.
I'm trying to find out how to start it. My thing is covered.
I could see it there.
The start button on the screen, I'll probably have to go down to a smaller size. And
it was there. I saw it for a second.
Yeah, I did too. Okay, now we've got the whole picture, but no start button.
You should be able to just tap on it.
I thought so too.
You got to get those pings, and you get worn out. It took me about 20 minutes on sideband to make a conversation with several people back home here in Chicago. We had Sked set up. Now, today's meteor scatter is done a little bit differently. The technique is the same with regards to everything else, but the mode is digital, and it's MSK 144, as somebody said before. This is done in a program that's open source. WSJTX is developed by K1JT and others. It's a great mode. We'll get into some of the details here. MSK stands for medium shift keying. It's continuous phase frequency shift keying, and the baud rate is at half the baud rate. It uses a message frame of 144 bits, and there's tone frequencies between 1,000 hertz and 2,000 hertz. The frame is 72 milliseconds, and that's where we started earlier saying 72 millisecond burst is what you need, or longer, in order to get a decode. But when it decodes, it decodes well. Just with the few dB above the noise level, you can get a good decode. Now, just to give you a little, everyone in the DX club here, is familiar with sideband and CW, and there's a few people said they're on FT8. Sideband, you need about plus 10 dB signal to noise in order to copy it. CW, you need about minus 15 for a good CW operator. FT8 is considerably better at minus 21, and JT65 was 25 dB signal to minus 25. MSK 144 is minus 8. So it's less sensitive than a good CW operator is. But we find that you don't need a lot of sensitivity here. When you get a ping, they're usually pretty loud. It really reflects the signal quite dramatically. So you don't need a very sensitive receiver, but you do need a decoder that can decode something that is happening very fast, in this case 72 milliseconds. So you need a good decoder. Now, if you have any questions, just feel free to chime in. I'll offer again before we go into a little demo about questions, or maybe after the demo. But if you got a question, you're not going to bother me if you ask it now, if it's appropriate. So go right ahead.
That won't work because this is not live.
Since there are some people on who have used the FT8, I use it. I think it's good. It's a tool, just like meteor scatter is a tool. You wouldn't use meteor scatter all the time. I wouldn't use FT8 all the time. But the sequence progression, FT8 and MSK 144 are essentially the same. So if you're familiar with FT8, half the battle is done already. And if you've got WSJTX loaded, as opposed to the JTDX, which does not have meteor scatter software in it, you're all set. Just a click of the buttons, a few buttons, and you'll be able to get on meteor scatter. Now, standard on 6 meters is 15-second time slots, transmit receive, just like FT8. A big difference is that there's no auto first call. And what I mean by auto first call is you have you can set up your FT8 so that you call CQ, and the first person that's decoded is the person the program is going to select to work. With MSK 144, that's not the way the software has been written. You have to sit there, you have to watch it. When you receive a ping and decode a ping that is targeted to answer your CQ, you have to double click on it. After that point, the rest of the automation can be turned on, and it will flow just like an FT8 QSO flows, but there's no first call. So if you call CQ, people can be answering you, but if you don't double click on their call, you're not going to start the transmissions to that particular station. So another difference is that stations hang in there an awful long time waiting for pings. You'll see some examples where it's not uncommon, 10 minutes listening to noise before they get a ping from you, and some stations are more than willing to keep going because they need your grid or your state or whatever. But a QSO can take as short as 1.25 minutes, like an FT8 QSO, or 10 minutes or longer. So, opts to hang in there for a longer period of time have a chance to make a few more QSOs. The other difference is on FT8, you have to wait until about 13 seconds in before the first decodes happen, and you get a chance to see what's going on and who's calling and who's on the air. In Meteor Scatter MSK 144, it's real-time decoding, so that even partially through the 15-second window, if a ping happens and it decodes, you will see that on your screen, and we'll go over that. So Here's an example of the real-time decoding. I'm going to get it going here. Unfortunately, I did not capture the audio, so you're just going to be able to take a look at it. You know, the sequence is 15 seconds, and that's why there's a 0 to 15, and we're listening right now in receive mode. If a ping happens, you'll see a little ping show up here. The vertical axis is your audio frequency spectrum, basically from 1 kilohertz to 2 kilohertz. And again, time is on the x-axis. When a ping happens, it will immediately show up here. There's a ping, and very light ping here. And you can barely see it on your screen, but that's the ping, and it decoded. And it decoded at 7.4 seconds in, which is about where it decoded, you know, and you're seeing the last one down here. So we'll wait for another ping to come in, and you can see this is a CQ from WA2BOT. He's on the East Coast. And we got the 2 pings are noted here, very light. They're not very strong pings. His signal levels, it was, you know, 1 dB and plus 4 dB, which are good, but they didn't show up as bright. You will see some brighter ones a little bit later, which are very dramatic. And for me, they're very exciting when I see all the really bright yellow and red colors. There's another ping, very light. And there's a good ping. Go ahead. Someone has a question? Okay. Anyways, this ping was decoded, but the second ping was not decoded. And it could have been because there was interference, and obviously it was long enough, but we did not decode anybody. So you don't always decode. So anyways, you know, that's the time that we have to watch this one. I don't think there's any more. TX messages.
Okay, sorry about that sharing incident there. I'm not very skilled at it, but so Mike kind of explained how it works. Real quick, I'm going to go back over to the other screen and show you real quick what that looks like, and then we'll listen to a couple of actual sounds of various VHF modes. Give me a second here, and I'm going to go back to the other screen. Okay, so this screen is there. The link is there. Sorry about the advertising. It shows a whole bunch of different sounds of signals, and it's actually up to date, and it's by EA6VQ. It shows as echoes off the moon, some aurora signals, and I'm going to go real quick to a very short range scatter recording on 10 gigahertz. It's what it really sounds like. I'm hoping you can hear this. Okay, and then we're going to go back and listen real quick to some HSCW, high-speed CW. On another slide, I'll talk to you a little bit about a high-speed CW activity, which is not as much as it used to be. This is 1,500 letters per minute, or about 300 words per minute, CW, just a very short burst. Did anybody copy that? Roll, did you get that?
And that's very sloppy fist.
You're exactly right. So 300 words per minute. I believe there's a fellow in Europe, a young man, who has copied call signs at a little bit over 200 words a minute. However, interestingly, as you noticed, it was very repetitive. And if you've listened to your own call sign at 200 or 300 words a minute, after a while, at least you feel like you can copy your own call sign when you've sent CQ a lot on high-speed CW. Let's real quick listen to an Aurora signal on 6 meters. So that was pretty clean. What I will tell you is, in intense aurora, as that shimmering curtain to the north flickers back and forth, the signals usually are a lot buzzier, or at least they are here. Let's listen to the 2 meter CW signal. Still very copyable, but a little bit swishier. And now we're going to listen to sideband signals from a strong meteor shower. Pretty tough copy on sideband, but there have been some long distance sideband contacts on 6 and 2 meters and even higher using Aurora. So that's a pretty cool thing. So anyway, it's kind of a neat site to listen to various signals. Here's a real quick, a short, an echo. Sorry, I didn't listen to that before the meeting. Let me try a different one. That one didn't sound so good. So that was a pretty strong echo off the moon. That's how you can tell your system's really working over a 500,000 mile path, 250,000 roughly miles out and 250,000 miles roughly back. Takes about 2.5 seconds. And isn't that interesting? He sent about a 2-second group of dashes, and then a half a second later you could hear the dashes coming back, but much weaker, of course. So anyway, if you follow that link, you can hear the various types of propagation on the VHF bands and what they sound like. Let's go on to back to the slides. Take me a second. So here's some rovers that I've had over the years. I don't have an active rover. The last time I roved, I used that really nice W8ZN rover that is parked about a mile from my other site up on the mountain, and I took it to a ham fest as a demonstration. But it's been a while since I've actually done a traditional rove. I've done some HF roving for state QSO parties going from county to county, but this was VHF and microwave roving that I started in. Actually, first time I roved, I think, was January of '92, and I actually had that vehicle, but it was FM only, so it wasn't tricked out quite the same way.
So Brian, some people have questions about antennas. It looks to me like you've got a separate antenna for every band. Are there, particularly someone asked if microwave bands, are there multi-band antennas, or do you usually have separate ones for each frequency?
That's a good question. So there are some log periodic array antennas. The company called Create in Japan makes such an animal. They have one that's very popular that I've actually used. I have one here that goes from 6 meters through 1296. It's not very efficient on the microwave bands. It's designed to have perhaps 5 or 6 dB gain on each of those bands, which is enough at 6 meters to have some fun, but probably marginally not enough at the microwave bands when in that very small space like you can see in the picture. This is a looper for 903 megahertz, 1296, 2304, and 3456. They're all in the range of 20 dB gain on that short boom, maybe a little bit less or a little bit more, but in the range of 20 dB gain in that amount of space. So that's why you have individual antennas for each band, because it's easy to get a lot of gain. But if you try to compromise by using all the bands on one antenna to make it easy to rove with, you give up a little bit to get a little bit. Fact of the matter is that the antenna that I used with this vehicle in 1992, I had a very high score in the June contest, had all my equipment in the back of the van, and I had one single antenna connected just inside the back door on a short mast, and it was in fact one of those create log periodic antennas, and I had the bottom 6 bands, and I had a lot of fun. Interestingly, this location is the Long Bay Bridge between Norfolk, Virginia, and the eastern shore of Virginia. I don't remember exactly, about a 30-mile long bridge. And I was able to introduce myself to the police chief. That's a privately owned bridge. And wrote a letter to the police chief and was able to ask permission to operate from there and got permission. I was there probably 30 or 40 times over the years. And you can't really tell from that picture, but that's actually a little raised roadway up above the entrance to a tunnel, so it goes down from there, and it's probably 30 feet above the water, and the line of sight is amazing along the Chesapeake Bay entrance and along the eastern coast of the United States, pointed towards Long Island. And eventually I was able to complete a 10 gigahertz contact from that grid, which is probably FM 17, but it could be 16 or FM 26 or FM 27, depending on which of the islands or the little protrusions that you're on, all the way to Boston, and several contacts in FM 31 and FM 30, New York City area, and up by where ARRL headquarters is in Connecticut. So when conditions are right along the ocean, you can do some pretty amazing stuff with a very minimalistic station. This station doesn't have a dish for 10 gigs. That was a long time ago. The station I'd like to talk about today is a little bit later, my second rover, which is this old Dodge truck with a camper on it. And that push-up mast on the inside goes to the center of the roof. And the way those antennas are turned is called Armstrong rotator. You use your strong arm and you rotate the antenna. And people think I'm a little weird, but if you have your headset on and you're listening to a beacon and you turn that antenna, you kind of get biofeedback. It's really easy to get a good, strong, correct bearing on a signal by listening to it and turning the rotator with your hand and getting that human feedback loop going to get the antennas pointed. Anyway, I took this rover up to the East Coast, the New England Weak Signals Club's annual conference up in Enfield, Connecticut that year, near Springfield, Massachusetts. And I took my rover up there as a demonstration, parked it in the back lot of the hotel and set it up. And it turned out that the folks that were doing the high-speed CW meteor scatter demonstration were having troubles with their antennas and their coax. They forgot something important. And fortunately, I parked close enough that I was just able to run my coax over and turn the antennas towards Georgia, and they used my antennas in the rover to make some sample meteor scatter, high-speed CW contacts. W3ZZ was one of the operators and a couple of European guys, and they worked Georgia on high-speed meteor scatter in the daytime, in the early morning, from Enfield, Connecticut to, I think, Atlanta, Georgia. EM84 or EM83. So that was pretty cool. And that was a long time ago, before MSK 144 even existed, much less was popular. And that rover had all the bands and didn't take too long to set up. We had a lot of fun driving to remote places and trying to give people some contacts that way. And so you can see from these pictures, I've had a lot of fun basically integrating equipment into trucks and trailers and going to unique places. Was there another question, Roll?
Tom's watching the questions. Tom?
Yeah. One question is, and you've kind of answered it, but how much activity is there above 2 meters?
The answer is
prominently 2 meters, or is it all across the bands, or what's the? Go ahead.
Certainly during the contests or an opening, there's activity on all the bands. With the advent of FT8, there's been a little bit of a bump in activity. That's a really good question. So one of the things I'll talk about, a long time ago, probably again early 90s, 1990s, a lot of our guys here in the Washington, D.C., Baltimore area, we would get together to work on our equipment on Thursday nights, and a couple of times a month, we'd have what we called MAD, Microwave Activity Day. And so on Saturday mornings, we would take all our rovers and our home stations, and we'd all coordinate with each other and work each other just to make sure our equipment was working properly, or our new features and additions could be tested out. So Microwave Activity Day still exists. It's the first Saturday of the month, so it just happened a few days ago, and at least along the East Coast, there's a lot of activity on sort of designated times. And we didn't talk about 10 gigahertz much. I was going to do that a little bit later. But on 10 gigahertz, there's an incredible amount of activity, especially when there's a rainstorm, again, in your area. Excuse me, I'm going to cough. So when there's a rainstorm, you can use rain scatter, literally bounce off the rain droplets or the thunderstorm clouds where the water is dense, and make contacts that way. And so whenever there's a thunderstorm, you'll see all sorts of activity. And then the meteor scatter stuff, I'm going to show you in a moment. There's actually a kind of a set of bulletin board or chat rooms where people connect literally every day to try and make meteor scatter contacts. Ted, you're smiling. Did you want to add something? Okay. Anybody want to add anything to that about my activity? The story that I tell, W3XO is kind of a famous ham. He used to write the VHF column in the QST magazine. And he did a little bit of a study of VHF activity and of VHF openings, really. And what I found was, in the summertime, if I get on 6 meters every day, I'll work somebody. There's some sort of opening on 6 meters almost every day in the summertime, late spring, from right about now, really, until about August, and sometimes in the winter, too. And what he noticed was activity really increased on the weekends and on contest weekends and on holidays. So my guess is the bands are open, but if nobody's active, you won't know it. And so the encouragement is to get on and call CQ other than on the weekends. And with all the chat rooms and the packet spotting networks and the RBN system and all that kind of stuff, if you get on, you'll get posted, you'll get heard, and folks will call you. Was there another question, Tom?
And I don't know what this is. Do you have any experience with AREDN, Alpha Romeo Echo Delta November?
I actually do personally. That's the Amateur Radio Emergency Digital Network. It's a microwave network, and my other site, before I had zoning issues, actually had an AREDN node there briefly. It is not up right now. So basically, that's a way of creating a emergency internet in the event of a catastrophic activity, and it's kind of a sidelight. It's not really weak signal activity. So, and I'm hardly the expert on it, but I can connect you perhaps to someone who is. There's a sort of a coordinator in my area that understands that stuff, and I just simply had a site at a mountaintop.
Roll could jump in. Is Andy going to cover that?
We don't have a ARCNEM thing here in Maryland that I know of, but there's a book. I won't interrupt to show it, but there's a book that's just come out. It's called Digital Networking for Ham Radio. It's specifically about AREDN, and it's also about HamWAN, which is another more European, but also another technique. And it's a very up-to-date book, 250 pages of information that you need to get started. But it's amazingly not so difficult as you might think it would be to do. As Ryan said, it's your own RF-connected internet, local internet, which can connect to the real internet also.
Yeah, so very good. So anyway, that's perhaps another subject for another time. And since that book is out and my knowledge is a little bit limited, thank you, Roll, for bringing that up. I'm going to show you a couple other things on that other slide in a minute, but let's talk about grids. If you do FT8, you need to know what your grid is. If you do VHF, most VHF contesting, instead of going by states or counties or ARRL sections, they go by grids. And so it's nice to know what your grids are. So one of the things I've done is I'm going to share the other thing. It'll take me a second. So this is my grid in a mapping program. You see it's FM19KJ49QH. That's my house. My station is located in the basement right about there. Okay, but my antennas are over here. And so they're in a different 10-digit grid. That's the bottom of my tower. You can see the shadow of my tower right there. So I'm going to click on the tower base. And it's in FM19KJ49QF. So it's a little bit off from QH where my station is. So I guess if I'm giving out 10-digit grids, I have to choose whether it's where the signal's coming from or where I'm sitting. Most people don't use 10-digit grids. You really don't need to. As you can see, that's pretty precise as far as location goes, but it's kind of a fun little sidelight of the whole grid thing. Now you look in the limit, those grids look like rectangles, and we're going to talk in a few minutes. They are not rectangles. It just appears to be within the limit. Another cool program associated with grids is called Grid Mapper, and the link is available. So this is my grid on Grid Mapper, and it shows all the stations. And so this is me right at the top of the grid. Brian, ND3F and Friends is the N3IQ call, and my call is ND3F, and the other club is K3MEC. It's located here because that's where its mailing address is. It turns out the station address is way over in Virginia at the mountaintop. So this is kind of fun to see who lives near you. For example, AB3CV Jim is a very active operator, and he obviously lives quite close to me. Good to know who's located close to you using that program. Let's see if I can escape. This is for later. I didn't show you when we were talking about digital modes, but this is the bulletin board called Ping Jockey. It's on the link to it is on a previous slide. Ping Jockey. It doesn't look like there's too much activity right now, but let me see if I can do an F5. So basically what this is folks that are trying to do meteor scatter contacts get on here and say, I'm available, I'm active, I'm using the first 15-second window, I'm running this kind of a station, 6 elements, 500 watts, and it looks like some people have been working along the East Coast here a little bit, even early in the day. One of the things about meteor scatter is the absolute best times for the loudest pings is between roughly local midnight and local 6 a.m. just due to the geometry. And so that's one of the things. Real quick, I thought I would, look at that. Let's see if I can reload. It's gonna take me a second. This is a remote to, oh, it might be up. Hang on, got to close up. Let's just take me a moment. Okay, so this is my station at this location. I'm obviously upstairs and the station is downstairs, but I can operate it remotely and show you the screen. So this is the display of the logging program currently running FT8. But if I click down here to MSK, you can't see it because it's on display 2. It opened that window that you saw, the 15-second window for MSK. So I switched over. I'm not seeing any pings right now, but this is the same screen. Yep, look at that. There was a little bit of a ping there. And I have to go back to the other screen to see the decodes. Of course, when I'm sitting there, I can see both screens at once. So I just thought I would show you that. And then I can also see my other station up on the mountain using the same program. Let's use left. There's a couple stations up there.
And Ike W3IKE is going to talk about.
He's going to talk about the details of remoting. So, for example, my station is running FT8. This looks like maybe 15 or 20 meters, 15 meters, and I don't get on all that much on HF up there. But this station is about 2,250 feet above sea level, and then the tower is another 50 feet above that. So 2,300 feet, and with a very small antenna, it's on 15 meters right now, running barefoot, and it has a nice 6-meter antenna, but the 6-meter antenna is down for repair right now. So I just thought I would show you that, and then back to the this is the next one I'm going to show you when I go back to the other screens. Okay, share slides. Okay, so let's, I'm not going to show you any of these other ones, but I showed you K7FRI. That was the first grid screen with the 10 digits. I showed you Grid Mapper. That's the one that shows all the call signs and addresses and names. If you click on this one, which I'm not going to do, this is basically a path profiler, and it's free. It's very useful. You can include the curvature of the Earth. You can include some information about the stations, and it will show you basically your probability of completing a contact at a particular frequency based on the terrain. So it's a pretty cool thing to use. And then the fun fact is, if you get on a Logbook of the World on the ARRL website, and you're a very active VHFer, it will show your grid totals by band, even at HF. All your FT8 grids will be shown, as well as the VHF ones. So that's a pretty cool thing. Having trouble getting to the next slide. Not sure what to do. Hang on a second. All right, let me go back to share. I apologize for not being efficient at the sharing. It's just, okay, can you see the briefing again?
Yes, yep, it's there.
Okay, so I won't spend any time on this because I know there's people that aren't on the East Coast. A long time ago, one of the most fun roving things to do was basically scout out new sites. And especially in the 90s, really before September 11th, there were a lot of pretty cool places you could get to that the owners would let you climb up their mountain or drive up their driveway and operate your equipment from them. After September 11th, a lot of things got private. And I don't think it's so true today, but one of the things I did to have fun roving was I wrote an awful lot of letters to property owners saying, I'm coming for the contest, is it okay? And then thanking them after, including the Chesapeake Bay Bridge. And that turned out to be extremely effective to get some buy-in from the local folks before you brought your rover and antennas there. And I even had a little trifold brochure that I would give out so that they knew I wasn't, that I was doing a good thing, maybe emergency prep or anyway, not something harmful with this crazy equipment. And that worked out pretty well. I still keep those brochures around just in case I go out to do a little grid exposition. Anyway, here's some really cool sites. If you ever get a chance to go to Spruce Knob, West Virginia, you know, it's a good portion of a mile high. It's a wonderful place to operate from. If you can get up high above all the clutter, it's pretty cool. You might say, well, yeah, but it's far away from the population centers, and it is, but when you're up that high and you have decent antennas, you can get to the population centers. So that's one of the cool things about VHF is if you can get high enough, you can really extend your horizon a long ways and take advantage of the propagation. So this slide is about the Fred Fish Memorial Award, working all 488 grids in the continental U.S. And sorry about that. And that's a pretty cool thing. I am not all that close. I'm in the 450s. You would think I would be on here, but the club stations are not eligible for the award. So anyway, I said last year that there were only 23, I think, people. It looks like there's more like 55 or 56 people that have completed the Fred Fish Award and have worked all 488 grids. And there's some notable people on here. W3LPL is about 40 away, and he's going to be one of the speakers in the ops class. And W3UR is one of the speakers in the ops class. He's at 457, so he needs about 30. And I don't know if he's on tonight, but Mike W3IP is very active in this area, and he needs one more. And to that end, he sort of piqued my rover button. I'm pretty sure that the grid that he needs is CM93. And as you can see, CM93 is off the coast of California, off of Santa Barbara, and it's mostly in the water. I'm going to show it to you in a second. And it's a most needed grid. So I'm hoping it may not be this year, but I actually have a brother out there and a connection to a boat. So I may be able to rove a Maritime Mobile and activate that grid. If not this year, perhaps next year. It's a pretty big undertaking from here to activate CM93. And you'll notice on the East Coast, all the grids are green, I guess because we all roved for a long time. Some of these grids like FN01 used to be orange. Almost nobody had it. FM 27, 26, and 25 were red and orange because nobody could work them. And FM 13 was a much, much needed grid. It was the last grid for Fred Fish for several of the early winners were some of these grids, and FN 67, which is still orange, right off the top of Maine. So as you can see, the East Coast is pretty well populated and pretty well covered. The West Coast, which is also well populated, has some really tough grids along the coast of Washington and Oregon and Northern California that are very remote and mostly water that obviously are very difficult to work. And you can see in Nevada and Utah and the West Coast, the low populated areas in the desert and so on are a little bit underworked. I need CM93 myself, so if I go out there and get on, I won't be able to work myself from back here. So that's a minor disadvantage of roving, is you can't work yourself from home. Now, hang on a second. I'm going to show you a picture of CM93 grid on one of these programs. Wrong one. Oops, wrong share, sorry. I don't think I'm sharing the right screen. Let me stop, share and share again. Here we go. Okay, so that's the grid CM93. Sorry that this thing is in the way. I'm going to turn it off. Santa Rosa Island off the coast of Oxnard, Ventura, Santa Barbara, that area north of LA, is the only land in the grid. And it actually counts for Fred fish. So unless you have a boat, it's going to be kind of difficult. If you notice, there's not a lot of population on Santa Rosa Island. And so those last few grids for Fred fish are kind of tough to do. You can see why that challenge might be a fun one to take on if you're a true grid enjoying person like I am. So let's get back to the show. Okay, and we'll go to the next slide. So a little bit more on grids. You saw that in the limit of the very small 10-digit grid, everything looks like a rectangle, but really grids look like a smaller version of that weird shape. If you peel an orange, a section of orange peel that looks like a rectangle in the flat, in fact, is not a rectangle in the 3 dimensions. And so when you look at the 2-dimensional version of it, it's a kind of a weird shape with curved sides and relatively flat top and bottom. So the distance from the top and the bottom is basically constant, but the distance from the right to the left changes as you go north, longest at the equator, almost 140 miles, and very short at the North Pole. In fact, at the North Pole, where all the lines come together, you can walk and put your foot in, one step in each of 180 grids. So that's heaven for a rover. You could literally do 180 grids in almost no time at all, just by circling your rover around one of the poles and pointing your antennas south towards where all the people are. So there's more to VHF than just working other guys and logging folks. The Irish Radio Transmitters Society have had an award for a long, long time, pretty much as long as I've been doing long-distance VHF, called the Brendan Awards or the Brendan Trophies. They're not all trophies. They're cups and medals and plates. Pictures of them there. And they are awarded to the person who completes a transatlantic QSO. Basically, the intent was North America to Europe or England, in particular Ireland, maybe. And hasn't been done yet, not officially. There's been a couple of bits, and there's been some QSOs from the Caribbean to Africa, which are transatlantic in a way, but don't meet the requirements for this particular trophy. So one of the things I, again, had hoped to do was put together an expedition to go up to the far northeast portion of Canada, and we had even picked out a site, but weren't able to get all the stuff together to do that. When do you think the right time to go after the Brendan Trophy is, based on propagation and what you know about 2 meters? Well, it turns out that somewhere around the longest day of the year, when the sun's out the most, the late part of June, the early part of July, is when these things happen. And interestingly, the closest have been in 2002 and 2023, separated by 21 years. The sunspot cycle is 11 years, so those 2 years are approximately the same spot in the sunspot cycle as we were last year. So 2024, 2023, and so we're getting actually past the peak probably for seeking the Brendan Trophy when the situation is just right to work across the Atlantic.
Sporadic E would count, huh?
Say it again?
Sporadic E would probably be how it would be done, or?
I suspect that it's going to be some sort of combination. The longest 2-meter contacts I've have been sporadic E, but or some sort of E-skip, but a combination perhaps of aurora and E-skip, right? Because you're in that northern zone. If you're up in the north part of Canada, where when the K-index gets high and there's something to bounce signals off of, ionization around the North Pole might be the way to go. And the longest 6-meter contacts I've had have been across the equator, but I've had some very long contacts to the north with a combination of aurora and something else. So I don't really know the answer, Roll, but the Caribbean to African stations, I think you're exactly right. It's some sort of sporadic E or E-skip, or possibly F2. The muff would have to get awfully high, which has only happened a couple times in our lifetime, to be able to cover a transatlantic path on 2 meters.
So have any of the shields or plates been awarded?
I checked about a month ago in March, and they had not, but I didn't actually, because I was checking last year to see about that trip. I think there was a little controversy with the 2023 thing. Not a good subject to talk about here, I don't think. But I believe the answer is none of them have been awarded yet.
Interesting.
But there have been some bits. There have been some partials across the pond. Just not a complete QSO. So anyway, that's a fun thing, right? The first, I think there used to be some money associated with it too. I'm not sure there is now, but to be the Brendan Trophy winner would be a pretty slick thing. So anyway, I know my time is a little bit over.
Don't worry about it.
I put the same slide up every year. This stuff is fun for me. It seems like after 60 years of ham radio, there's something fun for everybody, and the folks that I get the chance to share with, they seem to find their niche. For me, roving was especially fun because I could give out new grids to people, or new modes, or new bands. And I don't know if that's happening quite so much, but now it's new modes and new ways of talking farther. So there's always something. And I'm really getting, I don't know that it's going to stick. The last few weeks I've been doing FT2. I've mostly worked the same guys, but FT2 is the new thing, mostly on HF. But I think people are doing it so they can perhaps adapt it to VHF and above. And the first two things, just do it, and just do it safely. I just had somebody climb my tower today, and every time somebody does these days, I'm reminded that there have been some tower accidents with ham radio guys. I usually do a reminder that says, when you're scoping out these new sites, don't watch your GPS too closely. Focus on driving and not your screen in the car, because I do not want you to have an accident going out to have fun. If you have questions, it seems like every year I get a few really interesting questions, and if you're really getting into roving and you're interested, please contact me. I still have a fairly significant junk box with spelled JUNQUE, very high class junk, that includes antennas and mounting stuff and mechanical, and even some transverters and radios that could help you get on for roving. And I guarantee you the price is right. If you'll just get on that and make contacts, that's usually the price. So please feel free to contact me. Were there any more questions, my friend Tom?
Yeah, a couple. By the way, a lot of thank you, very interesting presentation and so forth from the participants. Someone asked, if you worked from Spruce Knob, were you in the national radio quiet zone? And if so, what did you have to do to operate there?
Oh, how such a good question. The answer is no. Spruce Knob is not in the zone, but a couple of nearby sites are. And there are some rules associated with the National Radio Quiet Zone. My other site is right at the edge of it, but it's outside of it. When I put up my beacon, I contacted them to ask if I needed permission to put up a very low power beacon. Of course, the answer was it's fine. W3IP, who I mentioned before, has also had some contact with the folks there. It's kind of a long story. There are some rules, but they have not, let's just say they've been relatively ham friendly, especially for rovers who are only going to go out and operate one weekend. And the quiet is primarily associated with signals coming from the sky to dishes. So HF, for example, is not usually a problem. 6 meters is not usually a problem, but I'm speaking for them. You have to, there is a place you can go to find out who to ask, and I've contacted them a couple of times and they've been responsive, and the answer has always been not a problem, for me at least. And I have operated from the mountain that Reddish Knob, which is very close to the site at the center of the quiet zone.
I have a question for you on that, because it comes up when I'm teaching. I know that if you operate mobile in there, there's no requirement. But if you stop roving, do you have to coordinate with them, even though you don't have a permanent station installed there?
Well, I don't know the exact answer. Just based on a couple, I guess 2 or 3 empirical connections. I don't think they care about rovers at all, but I still contacted them when I rove to Reddish Knob, and they basically said no problem. So I don't know if whatever they had going on was simply the time that I was there, but I knew when the contest was and when I was going to be there. And I understand what you're saying is it's kind of random. I'm driving around and I stop and I'm in the zone. It's not, I can't pre-contact them, and there's not like a hotline. So I think that if you know you're going to go into the quiet zone, which is in West Virginia, kind of off the beaten path, it's roughly, if I remember correctly, a 75-mile circle around the site. You might want to contact them. And my experience has been it's no problem for what we do, but it has not been a constraint. Does that kind of answer it, Roll?
Yes, that's good. My microphone is clicking off and on there. Yeah, that's good. I think the wording is a little vague. It's like you can't install a station, or it implies that driving through is okay, and putting up an antenna at your house is not. What in between there, it's a little vague.
Yes, exactly. There's a permanence factor to it, right? And so roving isn't very permanent.
Couple quick ones. Can you jump up a couple slides to the Brendan awards there? So I believe it says somewhere here you cannot use EME or satellites or so forth for this.
Correct. Terrestrial modes is what they call it, right?
Terrestrial
signal modes.
Okay.
You can use high-speed CW. I'm sorry, that's not true. Only for the shields. So if it's digital, not copyable by ear, CW or phone, basically, that's the original Brendan Trophy. No machine assistance, right? Literally copying by ear. The Brendan shields allow FT8 and Whisper and JT65 and MSK 144. Or high-speed CW, and I know that people have tried high-speed CW unsuccessfully so far. And then the plates are all modes permitted, but that does not. All terrestrial modes.
Terrestrial
permitted.
For everything. Yeah.
I left the word out because I was.
How does the high-speed CW work? Is that machine generated? Obviously.
It is, but no different than your contest keyer in M1MM, right? You press you put the message in the register and you hit the button and it sends it at whatever speed, and it's just the speed is really fast.
Way faster.
It's literally the same mechanism. You pre-program in the message and you hit the message key, CQ or the station's call sign and your call sign or the grid. Very simple, short messages. And like I said,
it can't. Does it actually key your transmitter? Because I'm not sure all transmitters can key that fast. Or does it send an audio tone?
I honestly don't remember, and I've done it. I think you just have to set your. It's not QSK, right? You just have to set your delay so that there's no break between the characters.
I just remember Ben used to W3. What's Ben? You know who Ben is. Anyway, he used to complain when some of his radios came out that they wouldn't send 80 words per minute, which he liked to do.
And 80 words per minute is below the threshold for HSCW. But if you remember Gene W3ZZ, Dr. Zimmerman, my good friend who became a silent key quite a while ago, he was there that time I did the demonstration with to Atlanta. He claimed that he could copy certain things just because of hundreds of times of repetition.
Well, Zimmerman claimed lots of stuff.
That's the right answer, Roll. Was there one more, Mr. Tom?
Yeah, Ted, go back up to the beginning. Ted wants to know about the mast on that deluxe rover you had, like on slide number 2.
Slide this one?
I think so. Yeah. How does that work? Is it pneumatic?
Oh, those are pneumatic masts. And if you look on the top there, that's one of those two things is an air canister, and just like a scuba diving tank. And so you can also use a compressor if you have a generator, right? But if you're going up and you're just running off of batteries, you fill up your compressor, your scuba diving tank before you go. And,
so that's what's on the roof of the van there.
Yep, I'm not 100% sure because they're different colors now. There's a blue one, but I believe that's the storage tank for compressed air to raise the mast.
There you go.
But also inside, you can't see it, where there's an operating position and a couple of desks, but there's also a compressor, small compressor. It takes about 15 minutes to raise that with a compressor. A small compressor like you can get it at Harbor Freight. And there's two of them. The one in the front is also pneumatic. This is like 40 feet, so it's quite a significant mast. Of course, you can't really drive with a 40-foot mast up, so you've got to raise and lower it properly to be safe. All of us who have gone roving have had at least one incident where we hit a tree, or especially a gas station pump overhang or a drive-through because our antennas weren't lowered properly.
How much does that thing weigh, the one on the back?
It is not light. I was able to pick one up in my younger days, but I'm going to say 350 maybe.
Ooh, okay.
I can't pick it up now. I can't even mess with it.
And somebody else asked, do you remove the antennas when you're driving? I would say that's probably yes. So
the answer is no. I can probably show you better on the other picture. Like on this particular rover, the one with the ambulance, that tower folds over the roof, and you can actually see the ends of two pieces of aluminum or steel L-shaped metal. It sits in there. I bungee it to the metal. I slide all those antennas down on basically an extendable mast so that they're flat to the top. And then on the very front of the ambulance, they hook with another bungee. So it doesn't stick out very far above beyond the front fender when it's all the way down. On the rest of them, like this one, when you compress that mast to the roof, the antennas are maybe 18 inches above the top of the roof when it's fully compressed. And the same thing with the one that, this one. So when you take that mast all the way down, it's just a little bit above the roof, about this level, when it's fully down. And those antennas are actually set up so that they don't set up too high above. He may take off this. I've never seen this one before. That's an FM antenna. It's vertically polarized. He may take that one off. I know when I've used it, there's no antenna on the top segment. And
Yep,
the lower,
I can visualize it now that you describe it. Yeah.
so it's not a perfect solution, but basically you have to get it down around 10 feet around here, 10'6", 11 feet, to pass through most bridges and stuff. And only when you forget and you go to that one that's only, a little bit lower than that, the gas station usually, where you whack it. And now we know why in most states they publish the height of their underpasses, because you got to stay below it. Very good question, by the way, and very logical. And one of the engineering things that goes into the design, right, is how low do you have to go? Roll, over to you, sir.
Okay, well, that was wonderful. I always enjoy it. It's always new stuff that I've never seen before. So thank you very much, Brian, for doing that. We need to talk more often than every year like we do. But we talk on the air every now and then, too, so that's great. I hope many of you will take Brian up on his offer to answer any questions. That's why we do this. We try to bring people here who know this stuff inside and out, or who know the people who know it inside and out. So don't hesitate. Thanks a lot, Brian. You're free to stay, but you're also free to go. Thank you.
All right. Well, thank you again, Roll. It's always a joy and a great pleasure. And thank you for inviting me. And thank you, everybody, for your intention and good questions. 73.
Keep up good work mentoring new kids, too. I love it. Okay. Our next presentation is by Jim Andrews. As